Okay. EKA aluminium, like aluminium, and it is invented after that gallium. Right. Mendeleev left the place for the gallium, right? And he given the name EK aluminium, just like the aluminium. Similarly, like that EKA boron, like boron, that is what? Scandium. SC. Germanium, I told you. EKA manganese, like technetium. TC. ठीक है. Now correction of doubtful atomic weight.
This is the third point in advantages.
Yeah, that is the third point, huh?
Yes.
Doubtful atomic weight. Okay. So correction were done in atomic weight atomic weight of some element. Like atomic weight is equal to valency into equivalent weight. Okay. Now I will explain it. Have you noted this? Okay.
Yes.
Equivalent weight. I'm writing it. Initially, it was found that equivalent weight of Be, beryllium, is 4.5. 4.5, and it is trivalent. And it is trivalent. ठीक है. Just a minute. valency is equal to 3, trivalent, right? Meaning of that. So the weight of beryllium was 13.5, right? We multiply 4.5 into 3, so we get this weight, right? That is the atomic weight. Correction.
Yes, sir.
Written, huh? And next part is what? And there is no space. There is no space in Mendeleev table for this element. So after correction, it was found that B is actually divalent. Divalent. That is V is what? 2. So the weight of B become now what the weight? 2 into 4.5
Nine.
is equal to 9. And there was a space between lithium and boron for this element in Mendeleev table, right? Correct. Now just understood this point. What I'm explaining here, actual atomic weight is what? Valency into equivalent weight, right? So initially equivalent weight of the beryllium is what? 4.5 and its valency is 3. Then we get the this much weight. But on this weight, there is no space in the Mendeleev periodic table, right? For this weight, there is no place. On that basis, here is the correction for their valency. So actually its valency is what? 2. So when we multiply its equivalent weight with the 2, then we get the 9. So its atomic weight become what? 9. And for 9, Mendeleev given the place in between lithium and boron. That's why this is the correction of the atomic weight. I hope understood.
Yes, sir. Understood. But how did you correct it from trivalent to divalent?
Because there is no place. Na? That is what? Hit and trial method, right? Hit and error method.
Oh,
So on that basis,
yes,
they
sir.
multiply by this one and they get the place, right? In between this one.
Yes.
Clear? Okay. Next part is what? See, some more correction मैं लिख के देता हूँ यहाँ पे. Corrections were done in atomic weight of elements are uranium, beryllium, indium, gold, platinum. Okay. Now we discuss the demerits of Mendeleev periodic table. You note this point.
Then, sir.
Then, okay. Now next, demerits of Mendeleev periodic table. Today I will finish this Mendeleev periodic table till here. Periodic table. Okay. Demerits of the Mendeleev periodic table. Okay. See, first, position of hydrogen. So as we know that hydrogen resemble both alkali metal and the halogens, right now. Hydrogen resemble both the alkali metals its position is what? First A, and the halogens seventh A. In properties, right? So Mendeleev could not decide what is the actual position of hydrogen. Okay, so I'm not going to write it. Right. This is the demerits. Second one is what? B. Position of isotopes. Position of isotopes. So, as atomic weight of isotopes different, different, right? They should have been placed in different position in main leaf table. Because main leaf table is what? Totally depend upon the atomic weight. And as we know that isotopes, for example, जैसे देखो यहाँ पे hydrogen 1 1 1 2 1 3, hydrogen, deuterium, and the tritium. So we are getting that mass is what? Weight is different 1 2 3. So when we are going
Yes.
to arrange these elements on the basis of atomic weight, so they should give the different position, right?
Yes, sir.
Uh, so this type of classification was not given by this Mendeleev.
These problems are still existing.
No, not is solved now, because in modern periodic table they are arranging the elements on the basis of their atomic number, not on the atomic weight. So atomic number is same. That's why they get the same position in periodic table. Clear?
Yes, sir. But position of hydrogen is still there. No
Position of
atomic
hydrogen is
number there.
difficult. Position of hydrogen is not satisfied, right? This is the problem. First one is problem, not the second one. Okay.
Yes, sir.
Okay. Now, anomalous pair of element. That is also one more demerits. Anomalous pair of elements. Elements, right? Say this. There were some pair of elements which did not follows sorry, which did not follow the increasing order of atomic weight. It means what? Elements are arranged on the basis of their increasing atomic weight, but some elements are what? Having
Did
more
not
atomic
follow.
weight is placed earlier, right? Now
Yes, sir.
see this example. Argon and cobalt were placed before potassium and nickel. Before potassium and nickel. Okay. Respectively, in the periodic table. In the periodic table, but having higher atomic weight, huh?
But then why they were placed ahead?
They're placing on the basis of their properties, right?
अरे हाँ octet.
Hmm. So here is AR and K, right? Here is what 39.9 and here is what 39.1. Okay. Here see this PE and I 127.5 and here is what 127, right? Here cobalt and nickel, here is what 58.9, here is what 58.6. Got it?
Yes.
CH, thorium and vanadium 232 and here is what 231. Now D, like elements were placed in different group. That is also drawback, huh? Like elements were placed in different group. Okay. See. So there were some elements like platinum and gold, which have similar properties, which have similar properties, but were placed in different groups. In main leaf table. In main leaf tables, right now, like that PT AU. Here is what 8 group and here is what first B, but they are similar in their properties. So this is also one drawback.
Yes, sir.
Now, one last one. Unlike elements were placed in same group, unlike elements were placed in same group. How? See this. I'm taking this first group. It is divided in two parts. First A and first B. Here I'm taking this lithium, sodium, potassium, rubidium, cesium, and francium. Now here I'm taking copper, copper, silver, यहाँ से लेता हूँ मैं, copper, silver, and gold. Nice. Now more reactive alkali metals. Normal elements. Here less reactive. Coinage metal. Transition element. Right. Now see this. Cu, Ag, and Au placed in first group, right? Along with sodium, potassium, etc. Sodium, potassium, etc. While they are different in their properties. Right. Understood this part?
Yes, sir. Understood.
Yes. So now next one is what? Modern periodic table. That is what modified Mendeleev periodic table also. Right. That
Yes,
is
sir.
called our long form periodic table. We will discuss about this periodic table and their properties. Right.
Yes, sir.
Okay. So today I'm going to stop this lecture here only. Okay.
Yes, sir. 1 second, I'm copying.
Just do it. Do it.